Hi, and welcome back to the FE exam review series where we focus on problems built around core fundamentals that will help you pass your FE exam. Today's problem is based off of subsection C, ordinary differential equations, under the subject mathematics. I highly recommend you try the problem first before you watch this video solution, and you can do that using the first link in the description below. The only way to pass the FE exam is to practice, and every practice problem that you do will get you one step closer to passing the exam. I hope you tried the problem. Let's get into the solution. Now it says a spring mass system is subject to a ramped external force that depends on position. The system undergoes force vibration and the equation of motion is given above. We're given four possible solutions and which one represents the general solution to this equation of motion. Now, a lot of times on the FE exam, they'll give you a lot of backstory and things that you don't really need. But the real goal of this problem is to find the general solution. This is a second order differential equation because I'm seeing this second derivative here. Additionally, it's a linear differential equation since there's no product of derivatives, there's no sines or cosines or nonlinear functions of y in this. And I'm seeing a forcing function here, so that means I have a non-homogeneous second order linear differential equation. So that's kind of how you go about labeling it. And how do we solve something like this? In general, when you have a non-homogeneous differential equation, what you're going to want to do is find a particular solution which accounts for the fact that the right-hand side is non-zero, and then you want to find a homogeneous solution, which is setting that right-hand side to zero. When you plug in the homogeneous solution, you will get zero on the right side, and then when you plug in the particular solution, you'll get whatever the forcing function is on the right side. So the sum of those two solutions will give you the total solution, the general solution, which will satisfy this differential equation when you sum them together. How do we find the homogeneous solution? Let's start with that. The homogeneous solution is what we get when we solve this differential equation. Y double prime minus 4y equal to 0. This is a second order linear homogeneous differential equation, which we solve using the idea of the characteristic polynomial. All we do is look at these coefficients here. On the y double prime, that's going to be 1, 1r squared plus 0r, because there's no y prime here, minus 4 is equal to 0. Or what we have is r squared minus 4 equal to 0. This is the difference of two squares. If we factor it, we get r plus 2, r minus 2 is equal to 0. So what we have is r is equal to plus or minus 2. Now, why did we go ahead and find the roots of that characteristic polynomial was because when you're solving a second order differential equation, all you really need to do is focus on that characteristic polynomial, which come from the coefficients associated with your differential equation. Once you find the roots, it'll split into three different categories. You can have real and distinct roots. That's this solution here. You could have imaginary roots where you get sines and cosines, and that's because if you have an imaginary term in an exponential, that produces sines and cosines, which is why imaginary numbers produce sine and cosine solution. And then you also have a repeated root. In our case, our roots were plus or minus 2. Those are real and distinct. So we have a solution type of this. If we go ahead and write down our solution for our homogeneous solution, that's C1e to the positive 2x plus C2e to the negative 2x. And these are our two roots here, that plus or minus 2. For the particular solution, the kind of theory there is that we guess a kind of solution. We guess a solution which is kind of the form of that right-hand side forcing function. Now, you can see that given a specific forcing function like a constant forcing function, you'd want a particular solution of a constant. If you have an exponential forcing function, you'd want a exponential particular solution. In our case, we have a linear forcing function, a 5x. So what we're going to assume is that the particular solution, yp, is of the form ax plus b. And that's the most kind of general linear particular solution that matches the form of our forcing function here. Now, all we do now is plug in what our particular solution is to our given differential equation. And to do that, we're going to need uh, y double prime, right? So the derivative of the particular solution is, if you take one derivative there, the constant is going to go away and you'll just get a. If you take two derivatives of the particular solution, then you just get 0. Now we can plug this into our original differential equation. We plug in the particular solution here. The double derivative was 0, and the single derivative was ax plus b. If we go ahead and plug this in, what we get is negative 4 times ax minus 4b is equal to 5x. Now, what we're going to do now is match the coefficients on similar terms. Before we solve the rest of the problem, if you're enjoying this video and you're learning something, consider leaving a like and subscribing for more content like this. Additionally, if you're prepping for the FE Mechanical exam and looking for a resource that will help you pass, consider checking out my software, FE Interactive. It's the third link in the description below, and it'll give you access to multiple different sections, practice exams, review and improve sections, as well as a tips and tricks section, which helps you use your calculator better and save time on test day. An analytics page, which ties all of the different pages together. You get data for each of those pages, where you can view, for instance, how you did on each exam, as well as a detailed solution manual for each exam, so you know exactly where you're making the mistakes, what exactly is the misunderstanding coming from. And all of those are tied together with an overall data point. The overall data point can be reorganized in terms of performance so that you know, what are my top 3 subjects? What are my bottom 3 subjects? Having this kind of data is super valuable since it helps you isolate your weaker points and fortify your strong ones. I'm confident that my software, FE Interactive, will help you pass the FE Mechanical exam. And again, you can check it out using the third link in the description below. You get 2 months of access for $29.99. Let's get back into the video. So terms with an x, we're going to match. So what we get there is negative 4a is equal to 5. And the terms on the b, we're also going to match, right? There's no x to the 0 term here. So we see that negative 4b must be equal to 0. So that b is 0. Okay, what about the a? The a we can see here is 5 over 4, and it's negative. So now that we found our undetermined coefficients, we just plug it back into the particular solution. We get a y particular equal to negative 5/4 of x. To find our total solution, we just sum our homogeneous solution and our particular solution. Remember, our homogeneous solution was equal to c1e to the 2x plus c2e to the negative 2x. And our particular solution was negative 5/4 of x. You can see here that that corresponds to choice number 3. If we go ahead and input that answer, choice 3, we see we got the correct solution. If you learned something from this video, consider leaving a like and subscribing. Thanks for watching. I'll see you in the next video. Goodbye.